Alrighty. Welcome back to our new chapter. This is going to be chapter 9. Chapter 9 and 10 are both going to kind of deal with some geometry topics, which is looking at different shapes and figures. Chapter 9 will focus on 2D figures, so your typical squares, circles, rectangles, all the 2D shapes. And then when we get to chapter 10, we're going to use some of the things we learn in chapter 9 and apply them to 3D figures. So something like pyramids, spheres, prisms, and different figures like that. But for now, we're going to stick with chapter 9. And the first two lessons on chapter 9 have to do with circles. Circles, we see these all over in life. They are kind of an interesting shape because as we look at a circle, right, there's no sides, and so we're gonna look at like what's different about them. How can we still find area and perimeter of them even though they don't have sides? So we're gonna jump into that with this lesson here. Learning target is for this lesson is just going to be finding the circumference of the circle, and we're going to talk about circumference in a second here. But really, the circumference is when we go around the outside of the circle, how long is that? All right. And to do that, we're going to look at our success criteria, which is I can explain the relationship between the diameter and circumference of a circle, and then I can use a formula to find the circumference of a circle. All right. So on your page, yours looks a little bit different than mine, but still kind of the same thing. So I want you to fill in these different little blanks we have. First of all, we're going to start with this. A circle, the mathematical definition of a circle is the set of all points in a plane that are the same distance from a point. All right, so if I take any point, right, and I would almost use like a ruler, right, I would say that this point right here is about an inch away. Well, this point is also an inch away, and so is this one, and so is this one, and this one. Right, and we can create a whole bunch of these points around the center point to where all of a sudden we just keep adding them and adding them and adding them and adding them and adding them. We start to see this circular figure start to take shape, right? A circle is just that, right? It's a whole bunch of these little points all put together that are all the same distance away from the center point. That means that this line right here is the exact same distance away as this line. And the same goes for that line, right? Both of those are the exact same as that line, or this line, or that line, right? Any way I split it up, I get the same exact distance there. Right? That point we were referring to that sits in the middle of the circle, we call that the center, right? So one of your blanks that's missing there, right in the middle, you should put center on there. That's kind of the middle point that all the points revolve around. Okay. Again, our blank that's kind of missing up here should say circle, right? That's kind of our shape we're working with. And we have a couple different measurements we use with circles, and you probably heard them in the past. We're going to review them and then get into a couple new things. All right. So first of all, let's take a look here at this bottom little section right here. So just one of those little lines, so from the center to the outside of the circle, we call this a radius. All right, so that missing blank that's right here, we should say is a radius. And the radius is the distance from the center to any point on the circle. All right, as long as I touch the center and I touch the outside of the circle, I have a radius. And we would say it's about like halfway across the circle. Um, if we think about like the Earth, for example, right? Halfway would be the center of the Earth. We would say that the outside of the circle would be anywhere on Earth's surface. To the middle of the Earth, right? That would be a radius. That's the distance there. This green line, however, represents something else, right? It goes through the center, but then it keeps going all the way to the other side. When we have a line or a distance that goes all the way across the circle through the center, that's the key part, right? The distance across the circle through the center. This is what we call a diameter. Essentially, it's just two radiuses put together that are the exact same. They form a line. Okay, so if I try and draw a circle here, again, bear with me, my drawings are not great. This would be a diameter because it goes through the center point. A lot of the times, like we like to try and trick you a little bit here, or other things we'll do, right? They'll draw a line that looks like this, and they'll ask, is that a diameter? Well, yeah, it goes from one point on the circle to another point, so that part's met, but it never actually hit this center point. So we wouldn't call that a diameter. The only time we would is if it does hit the center, right? So again, this little blank here, we should write in diameter, just like that. These are kind of the main vocab terms we're going to be using throughout this unit. Um, so there we have it. On the right side of your page, you have a little definitions. Again, a radius, we would just write distance from the center to any point on the circle. And then for the diameter section, we would say the distance across the circle through the center. Right, that through the center point is the main part there. What's nice about this is if we look at a little bit lower, we actually can find both radius and diameter if we have one or the other, right? We kind of talked about this before, but a diameter, or we'll use the lowercase letter d, is really just two radiuses put together that just happen to be in an exact line, right? So if I have one radius and then I have another radius exactly across, ignore that. If I have a radius and then one exactly across from it, we would say that that makes up a diameter, which is the same as two radiuses. Same thing goes for radius, right? If I know the measurement of a radius, right, I know that that's just half of what the full diameter would be. So if I know diameter, I would just divide it by 2 and I would get my radius. So there's a couple formulas we'll use there. Okay. One asks us to look at a couple circles here and to either find the radius or diameter. Now it kind of depends on which one you have, right? So in example A, we see that we have a diameter, right? It goes all the way across the circle. And it tells us that this is 20 feet. Okay? Since I'm looking to find the radius, I'm going to say that my radius is just equal to my diameter divided by 2, right? It's half of the diameter. Well, in this case, my diameter is 20, and if I divide 20 by 2, I know that I get a radius of 10 feet. Labels are going to be very important in these units, right? If it says feet, make sure your answer also says feet. All right. For the letter B, right, kind of the opposite thing here. I have my radius. I know halfway across the circle. I want to know the full length across. In this case, I'm looking for diameter. I know that my diameter is just two radiuses put together through the center. Well, in this case, it's 2 times 7 meters. So my diameter ends up being 14 meters. All right, I've got a couple try-its for you. Take about 30 seconds to do these. Remember, if it gives you diameter, find the radius. If it gives you radius, find the diameter. All right, really quickly, right, I have the diameter, 16, if you want to draw a picture. Right, diameter means all the way through the center. That is 16. My radius is just going to be half of that. Radius equals half of diameter, which is just 16 divided by 2. My radius ends up being 8 centimeters. For this one, my radius of the circle is 9 yards. So I know that halfway across my circle is 9 yards, meaning my diameter is just 2 times that radius, or 2 times 9, and I get 18 yards. All right. If you flip your page over, you see that we're going to kind of uh, look at this thing called circumference. We kind of looked at it right at the beginning of the lesson, and talked about how there's a correlation between diameter and circumference. And really, the circumference, all it is we would say it's almost like the perimeter of a circle. It's the outside, the distance around the circle. And the reason why we don't call it the perimeter of a circle is it doesn't really go with the rest of the perimeters, right? If I had a rectangle, we would call this the perimeter because I could just take, right? I could just take this side length, that side length, that side length, and that side length, and I would just add them all together and get my perimeter. Well, on a circle, I don't have sides. I can't necessarily just, say, oh, I'm going to measure that, and measure that, and then we're going to measure that, and measure that, right? We have these curved lines that don't really match up nice. Well, what old mathematicians has found, right? They looked at, well, what is the connection between a circumference and a diameter? And what they found is that if you were to like break a circle and you were to lay out it in a straight line, you would find this little ratio, right? So I take a circle and I kind of cut it somewhere and I roll it out into the straight line. We actually find that its diameter and its circumference has a ratio of pi. This is where we actually get this Greek letter pi. Right? And what it means is that the circumference of a circle is approximately, right? We would say approximately, it's not exactly, but it's close, right? It's like 3.14 times its diameter, right? So whatever the diameter of the circle is, if we were to take 3.14, and we know it goes on forever, of that diameter, copy it that many times, we actually end up at its circumference. If you ever listen to the pi song, it talks about how pi is the circumference over diameter. It says that right in the song. Um, and so we actually get to see that formula show up here in a little bit. It's written a little bit differently, but that's just kind of a little glimpse as to why pi is 3.14. It's just a relationship between a circumference and the diameter of the circle, right? So again, the circumference, when we're writing it in, is the distance around a circle. That's that blank bar on top. Right underneath it, we see we have like two different formulas. And the reason for it is, right, sometimes we are given a diameter and sometimes we're given a radius. Now, if we're given a diameter, we can use this simple formula, which just says, hey, take the diameter and multiply it by pi, right? Just like I said here, if I took my diameter and I took 3.4 copies of it, I'm going to end up right at my circumference. That's what this is saying right here. If I was ever given a radius, right, we know that a radius of a circle is just half of the diameter. So we would just need two of them to finish. So we're going to take 2 copies of the radius and just multiply that by pi. Now, when I'm writing these, I typically write pi first, so like pi times diameter, or 2 times pi times r. You can write this anyway, right? I could technically write this as diameter times pi, or I could write this one as 2r pi. It doesn't really matter, but typically when we hear about this, we always say 2 pi r or pi times diameter. Either one works. Um, if we know one of them, we're just going to use the formula that has the measurement we know, whether it's diameter or radius, and we'll go from there. All right, so you've got an example here. You just got A. I'll look at B in a second here. For this one right here, we can see that we have a radius, right? I go halfway through the frisbee, and I know that that's 5 inches. So I'm going to use our formula that has a radius in it, which was this 2 pi r. All right, and you're going to see this a lot where it says use 3.14 for pi. Now, when it says that, it means in your calculator, when you're instead of hitting the pi button, and getting a really, really long decimal, we're just going to do a little bit of rounding. We're just going to multiply this by 3.14. My radius then is, well, how far is halfway across the frisbee? It's 5 inches. After I do that, we can multiply this all together, and I end up getting an answer of about 31.4. Now, since this is like perimeter, perimeter also got labels. It wasn't squared, that's only when we do area. So this one would just be 31.4 inches, and that would be like 31.4 inches around this frisbee for an answer. Okay. If you were given an example where you have diameter, such as example B here, we can see that this is 28 millimeters across. Since I have diameter, I'm just going to use my diameter equation, which is pi times diameter. All right. Again, we're going to use 3.14 per pi. 3.14 times 28. If we type that into a calculator, we're going to get a circumference of about 87.92, and in this case, it's millimeters. And circumference is really nice because of that relationship we have between pi, diameter, and circumference. So we're going to typically note that when finding circumference, it's one of the more easier things we can do when it comes to circles. Right. I've got 3 try-its for you. I want you to see if you can figure out the circumference of each of these. Remember, in example 3, I'm given a radius. I'm given halfway across the circle. So I'm going to use my 2 pi r. And then in example 4 and example 5, I've been given diameters. So I'm just going to need to use pi times diameter. I'll give you a couple moments to do that. Pause the video and try it out on yourself, and we'll get into the answers in a little bit. Okay. Looking at number 3, I'm given a radius. So I'm going to use circumference is equal to 2 times pi times radius. In this case, it's going to be 2 times 3.14. Remember to round there. And then we're going to multiply by my radius of 2. This is going to simplify when I multiply everything out. 2 times 3.14 times 2. And I get a circumference of 12.56, and this was centimeters. For number 4, I'm given a diameter, so I'm going to use circumference equals pi times diameter. In this case, I've got 3.14 times 14, which when I type into my calculator, 3.14 times 14, I get a circumference of 43.96, and in this case, it is feet. Lastly, number 5, I see my paper plate is 9 inches across. Since it's all the way across through the center, that is a diameter. We're going to use circumference equals pi times diameter. We're going to round to 3.14 for pi. My diameter is 9. And when I multiply that together, we're going to get an answer of 28.26. Match my labels. This one is inches. Just like that. All right, that's going to conclude for kind of this first section of lesson 9.1. Next little mini lesson is going to look at, okay, what happens when we cut a circle in half, right? Instead of looking all the way around the circle, I'm only going to look at half, but then we have to incorporate kind of that flat side of a semicircle. But that'll be for next time.